Hi, I'm Everett. Welcome back to the shop. It's winter time here in Canada, and now that my furnace is finally shut off, I can do my intro. I got another project from work. What it is right now in the shop we have a highway tractor apart. It's got a Cat C15 engine in the front of it, a 1LW variant, and it's been leaking oil for a while. We're finding a number of areas where oil has been leaking out, and we're repairing those. One of the other guys is actually the primary tech on this job. But what we also found was that the what's called the front structure plate, there's a big housing that goes, aluminum housing that mounts to a steel plate, and that steel plate then mounts the engine and all the stuff on the front, like the air compressor and the power steering pump and whatever all else, the water pump, all that fun stuff mounts into this setup. Well, that plate for the front structure has a big crack in it, and we're fixing a couple other things while we're in there. That plate's done. However, we have been having trouble trying to get one in a timely and cost-effective manner. Due to the current COVID, everything else, parts are harder to come by and take longer to get and whatever. The plate itself is about $1,500 to $2,000. We'd have to get out of the States if we were going to be getting the actual 1LW unit. Cannot find anything in a wrecking yard anywhere nearby. However, my boss happens to have a stash of used Cat engine parts, and we do have one from a 6NZ or 6NZ, wherever you're at, wherever you prefer. This plate is almost identical except for a few minor differences. There are a couple places that are sealed with O-rings instead of just the gasket, and there are three counterbores that need to be opened up to fit the fasteners to go with the 1LW engine. So not a super complex project. Just need to open up some counterbores, and the trick is I don't have some of the proper tooling for some of this, so I'm going to have to come up with it as I go. But hope you find it interesting. So here we have the 6NZ cover. I need to wipe it up a little bit yet. These little studs have to come out. What they are they have a little spline on next to the head that wedges into the hole, kind of like a lug stud on a car, and they have sealing washers underneath them. Anytime you reseal a front structure, you have to change those washers, but we do need to pop them out before I can do any machining on it. Just using another old vise that my father-in-law gave me. Wrapped with a rag. This one needs a little bit of love. Hopefully that wasn't too loud for you. Not lined up. Oh, there. So that's what they look like. You see a little sealing washer there with rubberized insert in the middle. So yeah, these had to come out anyway. So now I just have to clean up the rest of the gasket material and just clean it up a bit more before I mount it to the table. So for the areas here that are sealed by O-rings on the 1LW case, this center portion here is actually an insert. It's not machined as a groove into the plate. This is just a pressed insert, and so is this. There we go. There's one. I'm just using a transfer punch to pop it out. There. It's supposed to be a 3/8 transfer punch. It's 373 thousandths, so it's just a smidge smaller. So now that the plate's mounted to the table, what I've done is I've lined up the center line of the coil with the center line of the hole using this, basically it's a tapered pin, large tapered pin. This was all turned at one time using the lathe. The taper here was also turned at the same time as the journal that it's being held by. So I pretty much just ran it down here and then ran the table back and forth until it fit best. This will get us within a few thousandths, or a few hundredths of a millimeter, thousandths of an inch, hundredths of a millimeter. we go. Which would be plenty close enough for our purposes here. The holes for the O-rings are within a few thousandths of an inch of 11/16. So we're going to use an 11/16 end mill to make our counter bores. The bottom of the hole will be certainly flat enough for the O-ring. The counter bores need to be just, well, the ones that are on the plate are just a few thousandths of an inch or hundredths of a millimeter over 11/16. So I'm using an 11/16 end mill. This was originally a 3/4, but it's been cut down and sharpened to roughly 11/16. We'll be within a few thousandths. So what we'll do is we're going to touch off. We're going to touch off, set our 0. Then we have to go to a depth of 85 thousandths. Just touching there. I probably could spin the end mill a little faster, but it's high-speed steel. I can go slower. It's okay. Thanks again for the oil pot, Phil. Just about there. There we go. There's our O-ring counter bore. Now, one last thing I need to do with this before we put the little insert in is the inside of the hole is about 325 thousandths. Well, we need to make it 375. And for that, we're going to use a 3/8 reamer. That way the little insert will grab, because it'll have a 2/1000 of an inch interference fit. And lots of lube, a little bit of motion lotion. And now we have a 3/8 hole. And now we can take our little insert and tap him into place. There we go. I'm just going to set up and do the other one here because I'm actually at home from work right now trying to get this done because we need this. So I'm just going to set up and do the other one off camera. I'll bring you back in after. So the last thing I need to do before I take this back to work and, well, go back to work is I need to enlarge these 3 counter bores, that one, and one over here. They're currently 13/16 of an inch, give or take 21 millimeters. They need to be taken out to inch and a 1/16, 26-ish, somewhere in that neighborhood, 26 millimeters. What I've done is I've set my dial indicator at 0, just touched off the tool in the bottom of the bore, and then I set that dial indicator to 0, got my knee set to 0 as far as just my stop point, and that's what we'll use as our reference. So, right over here. Crank this out till it's just about there. And so really, all I'm going to do is just take successive boring cuts out until I get it to the right diameter and the bottom face in the right depth. Perhaps I'm taking a little too much. Take a smaller cut. Okay. Probably could go a little faster. Yeah. Well, I think this grading may be the fact that I have my the thinner bar here. It's the only one I have at the moment, this style, so it's just going to have to work. I'll bring you back in when we're a little closer to size because, well, boring is sometimes boring. I know, overused joke. So I just finished up the third hole. We're now done. I just need to deburr and clean up the piece. But this hole here had a well, it has an adjacent hole that's touching it, so it's actually an interrupted cut. I was really concerned that it was going to break the tool bit at one point there, but thankfully it didn't. So yeah, I just need to break this all down, clean up the part, get all the shavings and stuff off of it, and then get to work, I guess. Anyway, I hope you found it at least marginally interesting. Once again, just want to say thanks for watching. Thanks for subscribing, those of you who have. If you haven't subscribed, that's cool. Thanks for coming by. It's good to see you. Otherwise, thanks everybody again for all your for the likes, the thumbs ups there, comments, the emails you've all sent, and well, and for those of you who've helped me in other ways, I just want to say thanks. I appreciate you all. I'll see you next time.